Okay, let's continue from where we stopped earlier. The next thing we have is a cyclic quadrilateral. A cyclic quadrilateral. When we speak about a quadrilateral, we are talking of a four-sided figure, plane shape that has four sides. And if we have such a shape bounded in a circle in the sense that the circle passes through the four vertices of this quadrilateral, then we call it what? Cyclic quadrilateral. That is a quadrilateral that is what? Bound in a cycle. Cyclic quadrilateral. The next theorem we'll look at is theorem 19. Theorem 19 says the sum of the opposite angles in a cyclic quadrilateral is what? 180 degrees. That implies that angle AXB plus angle what? AYB, because these two angles are what? Opposites. It will give us what? 180 degrees. And angle XAY. Where's XAY? XAY plus what? Angle XBY. XBY will give us what? 180 degrees. That's theorem 19. The next theorem we'll look at is theorem 20, which says the exterior angle of a cyclic quadrilateral is what? Equal to the opposite interior angle. In a cyclic quadrilateral of this nature, there's a point here that is just about the end of the circle. Okay? This is a point that is bounded here, and we can draw an exterior angle. That is adjacent angles. These two angles are adjacent. So from this theorem, we are saying that angle X is equal to what? Angle Y. Because the opposite angle to Z is what? Y. So we are saying that this angle, this exterior angle X is equal to Y. How do we prove that? How do we go on to prove such? We know that angle Y plus angle Z give us what? 180 degrees. So these two angles sum up to give us 180 degrees. And also the angle Z and the angle what? X will also give us what? 180 degrees. So therefore mean that what? So let's do that by side. We can say that Y plus Z is equal to what? 180 degrees. Right? Yeah. I can also say that what? Z plus what? X is equal to what? 180 degrees. So from this, we are saying that Y is equal to X, right? So therefore, it will therefore mean that what? Y is equal to what? X. For these two statements to be true, then Y is equal to what? X. Because from this we can make Z the circular formula. Z will give us what? 180 minus Y. And here, Z will also give us what? 180 minus X. Making Y and X the same. Do you understand? Let's write down. We can say that Z is equal to what? 180 minus Y. And Z is equal to what? 180 minus X. So it therefore means that what? 180 minus Y is equal to what? 180 minus X. So we can say that 180 will cancel what? 180 minus Y is equal to what? Minus X. And therefore Y is equal to what? X. So the opposite angles are the same. Let's take some examples to illustrate this explanation. Let's go over the theorem again. From theorem 19, we said that what? The sum of the opposite angles in a cyclic quadrilateral is 180 degrees. So these two angles are opposite. Angle what? AXB and angle what? AYB. So they will sum up to give us what? 180 and angle what? XAY plus angle XBY. XAY plus what? XBY will give us what? 180 degrees. Then theorem 20 says the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So angle Y is equal to the opposite interior angle, which is what? X. We have an example on the board, and this example says that PQRS is a what? Cyclic quadrilateral, meaning it is bounded by a circle. And the diagonal PS and QS. Where's PS? PS and what? QS. Okay. sorry, PR, and the diagonal PR. The diagonal PR and QR intersect at what? A point X. If SPR is what? 40 degrees. Where's SPR? SPR. SPR. That's what? 40 degrees. And what? PXQ, which is what? PXQ is 70 degrees. We have to calculate what? PRQ. 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 We have to find this angle. Okay? Very clearly, we know that this angle here. Alright, so let's wipe a part of the board to help us with this calculation here. Can I wipe this part of the board off? Are we done here?
Sorry, question.
Yes, what's the question?
The angle PRQ, is it just that half of it for the lateral?
PRQ. PRQ. You didn't say it. You understand? It's not saying SRQ, it's saying PRQ. Let's wipe this part of the board off. Okay, so from this we can say that now it will interest us to note that PX, we can say note PXS, okay, is what? Adjacent to what? Is adjacent to what? PXQ. So it therefore means that what? Sum of adjacent angles are what? Is what? 180 degrees. That's sum of angles in a straight line. So we can say that what? PXS plus what? PXQ is equal to 180 degrees. That is what? 70 degrees plus PXS is equal to what? 180 degrees. Therefore, PXS is what? 180 degrees minus 70 degrees, which is equal to what? 110 degrees. So that means this angle is what? 110 degrees. Alright? Now if this angle is 110 degrees, we know that the sum of angles in a triangle is what? What's the sum of angles in a triangle? You can remind me. 180 degrees. And here we have a small triangle. What's the triangle here? Triangle what? SPX. So in triangle SPX, we can say that what? 40 degrees plus 110 degrees plus PXS is equal to what? 180 degrees. So that means that PXS is equal to 180 degrees minus 150 degrees. That will give us 30 degrees. So this angle is what? 30 degrees. If this angle is 30 degrees, now remember, these two are sitting on the same curve. So if this angle is 30 degrees, that means this angle is also what? 30 degrees. So therefore, angle what? PRQ is equal to what? 30 degrees. Okay? So that question is solved. So let's go to, do you understand this question? Do you have any problem? So if you don't follow the theorem one after the other, you will be able to solve some of the questions because the theorems are consecutive. Now the next question says, from this diagram below, can you observe the diagram on the board? From the diagram below, O is what? The center of a circle, ACDB. This is the circle ACDB. So if this is the circle and O is the center of the circle, we can therefore say that, from this point we can say that this is the radius. Do you understand? Pay attention. Stop right here for a moment. This is the radius, and this is also what? The radius. It means these two are of the same length. So that's an isosceles what? Good. We also know that this is also of the same length with this. Alright? So from the question, what they are saying is that it is from the diagram below, O is the what? Center of the circle, ACDB. If CAO, where is CAO? CAO is equal to what? 26 degrees. And AOB is what? 130 degrees. If AOB is 130 degrees, remember the angle subtended at the center of a circle is what? Twice the angle subtended at any other point in the segment. So if AOB is 130 degrees, then ACB should be what? 65 degrees. Good. With this information, we can also say that this angle here, this is 130 degrees. We can also say that this angle is what? The angle we have here. We're already solving the question without writing. This angle, so let's wipe a part of the board off to better illustrate the calculation. Are we through with this part of the board? Are we all through? So permission so I can wipe it off. Okay, so let's make the diagram bold and clear. So we'll take the diagram again here to make it more visible. Okay, so we have the circle A, C, what? D, and B. This is the center of the circle O. And the information we have is that what? This is C here. So from the information we know that this angle is what? 130 degrees. And this angle is what? 26 degrees. So we can bisect this into two. We can bisect this here in half. We have to calculate the angle was OBC. Where is OBC? OBC, which is what? This angle. And we know that from what you said. So let's write, recall, angle AOB is equal to what? 2 times what? The angle what? ACB. So AOB is what? 130 degrees equal to what? 2 times what? ACB. That means ACB is equal to what? 130 degrees divided by 2, and that's what? 65 degrees. So this whole angle is what? 65 degrees. If this angle is 65 degrees, then we also know that since this is the center of the circle, therefore this is the radius, and this should be what? The radius. This should also be the radius. Therefore, we can say that angle, or triangle, the triangle AOC is what? An isosceles triangle. Triangle AOC is an isosceles triangle. So if it's an isosceles triangle, it therefore means that what? If this is 26 degrees, this must be what? 26 degrees. Are we following? Are we following? So, and the sum of the two angles here is what? 65. So angle, so we can also say that the angle OCB plus what? ACO is equal to what? 65 degrees. If these two angles sum up to give us 65 degrees, and we know that ACO is what? 26 degrees, it therefore means that what? We have OCB plus 26 degrees is equal to what? 65 degrees. Therefore, OCB is equal to what? 65 degrees minus 26 degrees. And that will give us what? What's the difference? 65 minus 26, and that's 39 degrees, which is 39 degrees. So this angle here is what? 39 degrees. And this angle is 39 degrees. We can also say that what? The triangle OCB is what? An isosceles triangle. Do we understand why the triangle is an isosceles triangle? This triangle is also an isosceles triangle because this is what? The radius, and this is also what? The radius. This point being the center. So if this is 39 degrees, this one must also be what? 39 degrees. So therefore, the angle, what angle are we looking for? The angle OBC is equal to what? 39 degrees. Because both angles are found inside what? The isosceles triangle. These two opposite angles are therefore the same. Can we take this in writing as we move over to more examples?